Hey, I'm George Coyne, Chicago, Illinois. I'll be talking to you today about resilient workflows and caching with Prefect, so let's get into it. Over the years, I've consistently run into situations where I've had to deal with cache data. Now, there are a lot of situations in which I want to skip over recomputing data that's completely valid and ensure that the downstream portions get to use the data that's been cached in order to generally save cost and save time. And oftentimes, time is money. So, Prefect, I was very happy to find out when I first encountered it, had thought of caching pretty robustly, pretty deeply. There was a lot of functionality already considered, a lot of functionality already supported, and most recently, we've come up with and unveiled our newest iteration on making caching easier for you, and that is cache policies. So previously we've had a couple different iterations on caching. I liked the last one, and it still is well supported. We call it cache key functions. I think it's really nice for very sophisticated situations and building your own logic around when to cache. But cache policies, I think, does a really good job of aggregating a lot of use cases for why and when someone would want to cache and surfacing it in a way that's very easy to interact with for users. So if we look over here on the left-hand side, we can see a prefect flow. Now, we're dealing with Major League Baseball data, MLB, and in this situation, we're going to be fetching some White Sox data. Sorry, some Cubs data. That was a slip of the tongue. We're going to be processing it to get some insights out of it, and the data fetching only has to happen one time for a few of these operations. We don't necessarily want to refetch the data if it's the same data. So here we use the first of our cache policies. And the input cache policy, and there are a few. There's default, inputs, task source, flow parameters, and then none, which is do not cache this at all. Inputs very simply takes the args that go into our function, and in the event that they are unchanged between invocations, ensures that the cache remains valid and sets the task to a completed state and passes through the previous result from the last run when the cache was created. And so in this example, we have a team name, a start date, and an end date. And in the event that none of those have changed, the data would always be the same on the output. So I'm going to use the inputs policy to ensure that provided the inputs don't change, the cache result is fetched and then returned for the downstream task runs to pick it back up. Now, another thing we can do here that I think is kind of relevant is the only other situation I could see that would make my cache logic invalid is if the code changes itself. So let's say we have team name, start date, and end date. Those are all the exact same. But let's say I add in something here, or wherever in my function that's going to change what the shape of the output is. I'm probably going to want to recompute my data as well. So I can add in another one of my cache policies, and I can add in task source, which is going to ensure that provided that the inputs don't change and the task source code doesn't change, that the cache remains valid. Now we can go ahead and run this just to get an idea of what our output looks like. And we can see this is pretty standard prefect stuff. But what we're interested in is seeing where cached becomes the state. It's a completed state, but we aren't actually running the code at all. We're going to be fetching the results of the previous run and passing that straight through. So that covers inputs and task source, which I think cover a lot of our different use cases. Another one is inputs and flow parameters, or just flow parameters. Now, flow parameters is a cache policy that uses only the flow parameters provided to the parent flow run to compute the cache key. So let's say anything else might change. The inputs to our tasks, we may have found new static values or various things that might be interesting to our downstream tasks, but the only time we really want to ensure that nothing has changed is if our flow parameters haven't changed. So let's say in this example, my flow parameters are just going to be at the very bottom here, sorry for all the scrolling, are just going to be team name, start date, end date. And if nothing else changes, then the only thing that sets a cache is going to be if provided that these flow args, these parameters, are unchanged as well. And so this is also a really common one. I think this is actually a good place to start for a lot of folks, that provided that our flow is kicked off the exact same way, that everything should cache straight through. Now, there are also oftentimes when I know, like let's say part of my flow is a task that fetches data, the next one enriches the data, and then the third one is going to be like some model training, or it's like the real meat and potatoes of what we're doing here. And it's reliant on a lot of external systems that we don't have control over. So we can't guarantee consistency or item potency or integrity for that function at any given time. So we should always run it. Now, if that's the case, then we're going to want to use none. And this cache policy ensures that it never caches. Nothing will ever cache. And it's generally not necessary unless we have a bunch of other tasks in our flow in which we do have caching configured in some way. This is just to be really explicit to make sure that if we've configured caching elsewhere, we don't accidentally affect the execution of this task. Now, another cool thing about cache policies is how easy they are to interact with each other. So in this example, I'm using a cache policy of inputs. So game data, file name, provided those don't change, then our cache is valid. Now, I can also subtract by the arg name. So this says, provided that file name has changed, or really we're saying that if the inputs exempting game data have not changed, the cache is valid. So if the only way that this would be invalid is the file name has changed. Now, another cool thing about caching in Prefect is that we can configure the storage of our cache keys externally. Now, by default, we'll store our cache keys somewhere local, like on our local directory, but we can configure this to be remote as well. And that way we can actually reference these cache keys from other systems. This is really nice in distributed or collaborative environments when we have multiple team members or we have flows that are not running on the same machine, which is very common. And so here I'm configuring the key storage to be an S3 bucket. I'm using an S3 block for Prefect Cloud and loading it. And here we're going to be writing the cache key out to that location. Our results, which are the actual outputs of these task runs, will be written somewhere else. In this example, they'll be local results, but we can configure that as well. So we can have like an S3 bucket with our cache keys, an S3 bucket with our results. A lot of optionality to ensure that the outputs of our flow runs are treated with respect, and we have a lot of control over how things are cached. Now let's look at adding these together. So we talked about this a bit earlier, but I showed you we can subtract, we can also add. So this is saying that this is both this cache policy and that cache policy. Inputs and flow parameters must be true in order for the cache to be valid. A nice thing that we have to ensure that our caches don't evaluate as valid incorrectly is cache expiration. So oftentimes in our prod environments, we have a lot of systems that operate irrespective of one another. And especially in data environments, we have data coming in and out without necessarily being respectful to any given unit of work. And so we know that because things change all the time, we can say like a cache expiration of like, this is true for a little while, but even if these new values come in, or the same values come in, that we might want to just expire the previous cache and recompute our results so that we can stay really in a pristine environment with anything that comes out. And that's really all there is with cache policies. We made it really easy to digest, and easy to use.